Okay, so I think we're ready to go. So hi, I'm Marc-Antoine. I work here at Hopper. I've been working here for about 2 years. Hopper and Quick, we're a travel company, so we're travel agents basically. And we back our data. We use data science to provide value to our user by telling them not to buy flight tickets when they're too expensive, and also to tell them when to buy them when they actually are at a good price. Before I start, I want to say hello to GDG Sofia. So we're working in collaboration with Boris Strangev, that is the organizer there. And basically, he presented something that is very similar to the talk that I'm going to present tonight. So he worked on a lot of the code that is in this presentation, and also he shared his slides. So I just want to thank him a lot for that. So yeah, Hopper is the #1 multilateral app in North America. I already told you what it does, so just go try it out if you're a traveler. It will be amazing. So functional testing. So I quoted Wikipedia because why not? It's a reliable source, right? So basically, functional testing, it's black box testing that focus on testing the functionality. So we have specs, requirements that are defined for every of our different features in the app, and we want to test them, and we want to make sure that we get reliable tests as if a user was using it, basically. So yeah, functional testing usually describes what the system does. And this is super important because a good test is readable, for example. So we went for UI testing for a ton of reasons, but the main three is we want to test our main funnels, and these funnels are well defined, so functionality-wise, specs, etc. We're not testing ready in a lot of our code because, well, it wasn't set up so that the business logic is testable independently, like in isolation. And also, we have a bunch of legacy code. The app is over 4 years old, and yeah, UI testing allows us to test every part of the app. And it's not implementation specific, so if we get rid of our legacy code and it doesn't break the tests, well, great. So we defined 3 main goals while structuring our UI tests. We want them to be clean, so separate the what and the how. We want to test the features to make sure that we detect most of the regression, hopefully all of them, and we want clear failures. So whenever something fails, we want to know where it fails, why it fails, etc. So for that, we introduced 3 concepts. The robot pattern. If you don't know about the robot pattern, please go look online. There's a bunch of good articles. I know Jake Wharton made an amazing one, a good presentation, so you can find that on his website. The robot pattern is basically, they know how to do the stuff, and the test that uses them will know what to do. So it will tell robots, hey, please do this with that data, and the robot will do it. The proof object, basically, we want to know when a screen is ready to be used. And we use what we call a proof object to make sure that the screen is ready. So for example, a proof object can be a button. If the button is there, it's ready to use. Just click on it. And we also have steps. So our testing, since it's UI testing, we test the app from the start to the end. We test a lot of things in there. And we wanted to split it in logical steps. This will allow logging, but also having external steps and stuff like that. I'll talk about that a little bit later, but it will help you identify why the test failed. So let's see it in action. When we have a test report, for example, a failure, as you can see there, we have a picture on the screen, we have the crash at the bottom, and we also have a bunch of logging in the middle. So the logging is quite interesting. We know which test ran, which is useful. But also, we have a bunch of preconditions that we're testing. So I've put them in green there. We can ensure that the user is logged out if we want to try to log him in, and to know if a traveler exists before actually trying to select it. And it can also take actions if needed. And then we have a bunch of steps, robots that are tied to pages, and we can know when they're loaded, when they're started, if they're skipped, if they're optional, for example, etc. And at the bottom, we see also if it's not loaded in a timely fashion, we'll know that it failed, and we'll take the screenshot. So yeah, basically that's the logging that our steps provide. So now, how did we do it? So the robot pattern that I mentioned, Basically, each screen will have a robot class, and I use screens because it doesn't matter what they are, like activity, custom view, whatever. Like it can apply to anything because it's just a class that knows how to use a specific screen. You define the element on the screen that you can interact with, ideally as private because you don't use them directly. You'll define actions, so basically functions, to be able to interact with them with whichever data you need. This data should be provided and not hard-coded, so hopefully. So basically, that's what it looks like. We have a new profile robot. Basically, when the user tries to access the profile page and that they're logged out, we will show them that they can log in, for example. So we have a sign up or login button, and then we can click on it. We can fill in username. It's not actually part of that robot, but I put there to show that you should provide the data when needed. So if we do a test like the sign-in, we want to open the home screen, and then from there we open the trips, and then we have a new profile robot that can click sign up, and etc. Then we have login onboarding. So basically, the click sign up can return a new robot that will be used to interact with the next screen, and then we can assert that the last robot actually loaded properly. Since it's also a fluid interface, you can just chain them together, but I'm not a big fan of that because we don't know that, for example, click sign up actually return a different robot. So I prefer something else, and Kotlin can do much better for that. The robot pattern shines the best when we use it with functions, especially extension functions. So it doesn't look like a lot, but we have a class with the new profile robot that we construct. And then we have a function. Oh, did we lose visual? Okay. Or is it? Am I breaking anything?
No. Fine.
Oh, maybe. Cool. As if nothing happened. Okay, so basically the function to create the new profile robot is interesting because as second argument, we'll just ignore the test context. It's just a context containing a bunch of stuff we need for the tests. But the second argument is actually interesting. It's a function, but not any kind of function. It's actually an extension function on the new profile robot, which means that this function, in the context of that function, the this keyword actually referred to the instance of the new profile robot on which it is applied. So that will allow us to do something like that. When we create the home screen robot, instead of calling the class, like initiating the class with the constructor as we do usually, we're just going to say like home screen robot with the test context, and then we'll have a closure there. And as I put in comments, you have the this, which is the home screen robot at that point, and you can call the function of that home screen robot directly. It makes it a lot cleaner. And also, shout out to Android Studio for being awesome. It will tell you in gray, like, oh, this is actually this Spring robot. So you also have the context of what you're calling your functions on as you go through the code. So I put them in comment to show it here, but it's actually visible for free in Android Studio. So yeah. So as I said, the function is an extension function on the new profile robot, and then we just call apply to apply the function on the instance we just created. And apply works the same way as our extension function, but it is actually an extension function on a type where it takes a lambda that is, or a function that is an extension function on that same type. So you can actually call the function and then it returns itself. So that means that the new profile robot will also return the robot. So you can set it up in the function that we pass in argument, or you can also use it afterward. So this is what it looks like. The home screen robot is usable in the lambda that is the curly brace right after it, but also it can be returned and assigned or reused in other contexts. It's the same thing as doing this open trips, basically. So the click sign up function is returning another robot. So the interesting part of that is that you can also put an extension function for the robot it will return as an optional argument, and that allows you to easily chain the calls for that login onboarding robot right after the click sign up. So here, like we just created, we pass a function to the function that will actually create the robot and apply the extension function. So yeah, this is what we've been seeing. The click sign up in the middle is actually applying it on the login onboarding robot. So it's all chainable, and yeah, so you can have clean tests that actually tells what you're trying to do. So swipe through all tabs and not, please select the UI that have like a children that is that color and that ID and blah, blah, blah. So it's a lot more clear. So now that we have that, we'll talk about the proof object, because we've been creating robots that correspond to screens, but we also want to know if the screen loads properly. And I haven't shown that yet, but we actually have some code when we create the robots to wait for the screen in a timely fashion and just say like, hey, it loaded, or oh, it didn't load it. And the UI object is basically it's something from a UI automator that we use for the test, but it can be like espresso test or anything, like that's just what we use. They're not immediately resolved. They're basically lazy, and when you use them, it resolves them. So we define an annotation that is called the proof object. And basically, with some magic with our TestContext that I won't have time to demo tonight, we're able to get the proof object and wait for the page to load. Like basically, is the proof object available at some point in time? And if it does not appear in a timely fashion, let's say 5 seconds or whatever you decide your load screen should be, well then it will just throw an error and fail the test, take a screenshot, and you'll see in your test step that step failed. So the proof object here is, for example, our sign up or login button. We know that if the button is visible and usable, we click it, and that's it. Like it's ready to go. And the first argument of the new profile robot, the only argument actually, is a TestContext, and this will be able to get the proof object and make sure that the screen appears appropriately. So yeah, the TestContext, I skimmed over it a little bit, but basically, yeah, it knows the proof object, it knows how to get it, validate it. It knows if there's optional screen that can be skipped. That's part of our step process also. And each robot have a TestContext that is shared through a given test. So this is super important for a bunch of reasons. For example, it holds the Android context, our test logger, the UI automator, but also we check for ANRs during our tests. So if anything raises an ANR at some point, we want to know it as soon as possible during our test so we can actually crash the test and say like, well, you produced an ANR. So the optional screens. We do have a bunch of optional screens. Think of, for example, an onboarding process. Sometimes it's there, sometimes it's not there. Your tests don't necessarily have to care about it. It can, but it doesn't have to. So if you have like a bunch of optional steps, you can easily skip them or decide to go through them manually. And yeah, so it's just to make things easier and basically seamless. So each robot can define optional pages before or after their own screen also. So for example, if we have an onboarding for, for example, in our booking funnel, so we want to search for a flight, and then we want to book it. So to book it, you need to create an account. So if you're logged out, you may have to log in. This is a kind of optional step that we don't really care about. We just want the user to be logged in. So if it's not logged in, we're going to log in one of our test users, and that's going to do the job. So an optional page actually looks like that. It's a robot that can define the execute skip steps. So this is our onboarding. When we launch the app, we may want to skip the onboarding, so we just say like do this, do that, and then it's ignored basically. Yeah. So the test structure. We use test steps because it allows for better logging. We can know when it starts, when it finishes, relevant information about it. We can have the optional steps, so being able to skip them. And we're also going to log if we go through them, if we skip them, etc. So that if something happened that is shady, well, we'll know like, oh, okay, maybe it only happened when we actually don't skip that step. And we also have the ability to hook into them. And what is interesting about that is that we have a lot of features in our booking funnel, like a lot, and we're adding more to it. And a lot of these features are actually optional. And they will default to be false, for example. Like if you don't use it, it doesn't do anything. So with hooks, what we can do is like, oh, before that step, I will actually want to do some extra steps. So before that step, call this robot and do this. So basically, we can say, go through the regular flight funnel test flow, but also do this step at that point. So that's super useful to define like test and isolation, like just regular funnel with this extra step. So how do we define the steps? We just say, okay, here's a test step that I call open settings, for example, and here what the robots need to do. And the test step are basically extension function on any TestContext folder, which means any robot or test can actually call with test step, and it return whatever the step body, which is an extension function of that TestContext folder, will produce. So basically, when you call with test step, you can chain that after a robot to create a new step, and then you can use the robot inside of the step body because it's an extension function. You can return another robot, and then on that new robot, you can decide to do another test step on it, for example. So the test step is where we're going to log and execute like everything that is to be executed before the test. So all the hooks I've been talking about. We'll have some more logging, checking the ANR in the step, and then we'll execute everything that is after the hook, after the step body. So the hooks for after. So you can chain them, as I said. So the sign-in is a test, so I can call it directly with test step, and then I have my own screen robot that is returned as part of the test step, and then I can just chain another test step to actually use the robot. And then, for example, on the second block, I have the click sign up. Well, the click sign up return a new robot, so I can do the with test step with the scrolling intro, scroll sign intro, for example, that will use the new robot. And we also built a bunch of other things inside of that I won't really have time to demo tonight, but I would love to. We have prerequisites, so basically annotations that are handled before test to say like, hey, I would like the user to be logged out. That's what we've seen at the start, the two green actions that I put, like, yeah, if the user is not logged out, just log it out. It's a skippable step that we don't really care about. We just want to make sure that when we start the test, it's actually true. Another bunch of things is like, I want a credit card to be present because I want to use it, or I want it to not be present because I want to try to add it. And we can also test against ANRs. We use ANR Watchdog, which allows us to like hook whenever there's an ANR and like being called, calling a callback. So that's where we'll update our TestContext to just say like, hey, we have an ANR. So at the next step that you check it, just say it. So thank you for listening. If you have any questions, I think we have time.